Hello, today we'll be doing question number 7 from the pre-RMO 2017 question paper. In this question, it has been said that we need to find out the number of positive integers n such that root over n plus root over n plus 1 is less than 11. So we need to solve this. So we basically find we've been given that this is the condition that we need to satisfy. Root over n plus root over n plus 1 is less than 11. So now this can be further written down as if we multiply root over n plus root over n plus 1 into root over n plus 1 minus root over n, and we divide the same thing in the denominator, we write the same thing in the denominator. So we multiply and divide by the same thing, okay, and this is greater than 11. So this can be further, this is written down as we'll have n plus 1 minus n upon root over n plus 1 minus root over n, and that is equal less than 11. So we have 1 upon root over n plus 1 minus root over n is less than 11. So that implies that root over n plus 1 minus root over n is greater than 1 by 11. So this we can write it down as equation 2. Now from equation 1, this thing can be further written down as, if we take it, so we have root over n plus 1 will be greater than root over n minus 11. Okay, so this we can write it down as equation 1 rather. So now this can be also further broken down. We can write it down as root over n plus 1 will be greater than root over n plus 1 by 11. Okay, root over n plus 1 by 11. Okay, so this is the structure. Or maybe let us the thing is that we have to make the structure such that we cancel it out. So the structure that I am following is not unable to cancel it out, so we have to follow some other procedure. So what we'll try to do, we have to, let us just take these things out. There is no equation 1, and let us take this equation thing out also. Okay, we'll continue with a new step. Okay, so this we have as equation 1. Okay, so we have to make this sign also negative over here. So we'll write, if we take this entire structure over to the other side, so we have root over n minus root over n plus 1 will be less than minus of 1 by 11. So this will be equation 2. So now what we'll try to do, we'll add 1 plus 2. So 1 plus 2 upon adding, this will give us 2 into root over n. 2 into root over n will be less than 11 minus 1 by 11. Okay, so now we'll proceed with this structure. So this would be 2 into root over n will be less than, we have 11 over here, then 121 minus 1, so this will be 120 by 11. So we have root over n is basically less than 120 by 11, 2 into root over n. So this can be further written down as root over n will be less than 60 by 11. Okay, so that means that n will be less than 60 by 11 whole square. So that implies that n will be less than 3600 divided by 121. So let us find out this value. So 3600 divided by 121. Okay, so basically this will go up to 2 times. So we have 242. So this will be again 8, and then 5 minus 4, we have 1 over here, and then we'll have basically 118. So 118, and then we have 10 over here. Okay, so 121 into 9, how much is it? 9, then we have 18, and then we have 1089. So 29. So we have 1089. Okay, and the remainder will be somewhat in the range of basically 91. Okay, 91, we can have it as 91. So 91 is the remainder. So as you can see over here, n is less than 121, and then we have 29, or rather, this is not the correct way to write it down. N will be less than, we have 121 over here into 29, and then we have 91. So as you can see, n is less than 29 into something. Since n is an integer, so basically n will be less than 29 since n is an integer. So the question that we needed to solve, the value that we needed to find out was that find the number of positive integers. So we have basically n is less than 29. So if n is less than 29, so this is equal to 29, everything is said. So we can basically have 29 integers. 29 integers are possible. So this is the answer that we're looking for. We'll be solving the next questions in the subsequent videos. Thank you very much for watching this video.